Little 3.5 with regression lines. We did an activity. We kind of made our own regression line. A regression line is a line that models how a response variable y changes as an explanatory variable changes. Regression lines are expressed in this weird form where they use this weird y symbol. It's this y hat, you know, pronounced y hat. So we'll use that for regression lines, and they kind of do it backwards from your Algebra 1 days. You're very used to seeing this guy, y equals mx plus b, where the slope is the number in front of x and b is your y-intercept. That's still true, but for some reason, they like to put that last. It just makes sense to statisticians to put the mx right here and the b right there. So just remember that slope is in front of x. So then today we'll learn about what an extrapolation is as we go through. Let's just define it right here. It's the use of a regression line for a prediction outside the interval of x values to obtain the line. That's kind of like on our activity. We had data for 7 rubber bands for the Barbie, and then they said, okay, use this data to predict what 20 rubber bands would do. That's an extrapolation because it's like, okay, we don't have the data for 20 rubber bands, so we'll extrapolate it out to what it would look like with 20 rubber bands. And then this weird word, this residual, looks like it's going to be complicated. It's not once we dive into it. It's the difference between an actual value of y and the predicted value of y using the regression line. So it's the difference between an actual value of y and the predicted value of y. And then this is how to find it. We'll do more with that later. And then the y-intercept and the slope. The homework's going to ask you a lot of questions about the y-intercept and the slope today. The y-intercept is the predicted value of y when x equals 0. The predicted value of y when x equals 0. And the slope is the amount the predicted value of y changes when x increases by 1 unit. So whatever x is, when it goes up by 1 unit, that's like the slope of that situation. So there's all the vocab. It's blah. Let's put it to play with some actual problems right here. So here's what's going on here. Everyone knows that cars and trucks lose value the more miles they're driven, right? You know, it's like you own a vehicle, the more miles you put on it, it loses value. So can we predict the price of a Ford F-150 if we know how many miles it has on its odometer? Here's a random sample of 16 Ford F-150 Super Crew 4x4s was selected among those listed for sale at autotrader.com. The number of miles driven, and the price are our two variables right here. So can you see they made miles driven be your x value and the price be your y value in that situation. They put it all into the applet and they did the residual line, and it turned out to be this nasty equation right here. Y hat equals this guy, where x is miles driven and y equals price. Boom. Here's a magic word, predict. Predict means you're going to use that equation up there. Predict the price of a Ford F-150 that has been driven 100,000 miles. So again, in class today, we're using Mr. Bonesteel's calculators because you can see what's going on really easy. All we got to do is put 100,000 in for miles, which is x in this scenario. So let's punch that in, if you would. Let's do that together. 38,257. Take away 1629 times 100,000. You can use the multiply button. I always just end up using parentheses. Sorry. Make sure you got the right amount of zeros. 100,000 should have 5 zeros on it. And then just hit equals. So would you believe that using this cool regression line, that the predicted price of this guy is 21,000 something, 967? That seems about right to me also. It's like, all right, I got me a truck. It's a 2016. It's got 100,000 miles on it. It's a 4x4. It's like how much? 21 grand, 22 grand, you know. It's not far off. It seems reasonable in that case. Identify the slope. Could you guys just tell me, help me, which one of these two numbers is the slope? Is it the orange number or is it the blue number right here? Which one is the slope, orange or blue? The blue one. Positive or negative guy? He's negative. So our slope is negative 0.1629. And here's what it means. This is how the homework program is going to word it. Like for every mile driven, would you believe mile driven is our X values? So you talk about X. For every mile driven, the price is that Y value right here, goes down. The reason why it's down is because that slope is negative. And then it's just whatever number it is, $0.1629, which isn't much. You know, it's like 16 cents. Every time you drive a mile on this truck, according to the regression line, the value of the vehicle goes down 16 cents. It doesn't mean that that regression line is true. It's just based on the data. This is what the regression line shows. So this we'll take to heart if it's really true or false in that situation. What's the y-intercept? That's this number right here, right? That's this number right here. And then here's what it means. So the y-intercept is 38,257. With 0 miles, the truck has a price of $38,257. That's what the regression line's y-intercept means. If there were 0 miles on the truck, it has a price of $38,257. Some homework questions are going to ask you if that's even possible. Let's talk it out. Is it possible for a vehicle to have 0 miles on it? Like brand new vehicle straight off the lot. Do you think it'll have 0 miles? It's unlikely, because would you believe that they have to like drive the vehicle a little bit just to get it on the truck, to haul it to the dealership, and then they take it to the dealership, and then they take it off that, and then they drive it around to like the service department to get all the things cleaned up and do this? Would you believe like a brand new vehicle off the lot probably has anywhere from like 6 to 10 miles on it? You know what I mean? Because they've been driven around. But it is humanly possible to have a vehicle with 0 miles on it. You're probably not going to own it at that point. Does that kind of make sense? So, use the regression line to predict with 300,000 miles. I'll let you pause the video and punch that number in. So we got it all punched in. Did you get this? So we'll write that down. Negative $10,613. That's what this regression line predicts the price of that vehicle will be. Do you think that that's a good number, a realistic number, that if this truck had 300,000 miles on it, it is worth negative 10 grand? Yeah. You know why that's gave us that? Because this regression line, this is what's called an extrapolation. This line will predict things very accurately in this range. You know, from 0 to $160,000, it's going to do a pretty good job, or not dollars, but 160,000 miles. It's going to do a pretty good job. But once you get past that, it's probably not the best line for the situation. Does that kind of make sense? So once you get big time, because trucks have 300,000 miles on it, that happens, you know, and it's like they're still worth something. So we definitely don't use the line. The farther out we extrapolate, the less accurate the number's going to be. So, boom, let's kind of try this guy again. There's nothing to do on this problem. Hang with me, guys. I need to show you what a residual is.